This is a new link.
Yes, it is a link posted on Moodle, okay? So we will correct together the assignment as a revision for the exam. So for problem 1, we have the following table shows the results aiming to do the analysis of performance of different energy efficient solutions in reducing energy consumption, cost, and carbon emissions. So as you can see here, we have several criteria, LCOE, CO2 initial cost, and for different alternatives, we give scores in different units, of course. So we need to normalize these scores. According to the questions, they will tell us if we need to normalize from between 0 and 100 or between 0 and 20. So they can impose any score they want. So all you have to do is to apply the formula to scale to 1 and then multiply by the score desired. So if you want to put a score on 100, you normalize to get a number between 0 and 1, then you multiply by 100. If you want a score on 20, you multiply by 20, etc. So this is for the following table. In general, we were used to give the table of questions. So we ask people, what do you prefer, option A or B, put a score, and we did use this table. So what is a little bit new here is that we reversed the question. Okay, they gave us here the table after doing the analysis of scores, and we will do the reversed way. And from this table, we will deduce, if you want, what is the scores that we consider in the questionnaire. 1 second, please, Bas. It's okay. So here, instead of deducing this table, okay, we need to draw it. We need to draw the questions of do you prefer option A or B and what score you will give. And it's really simple. What will be different just is that here they already did all comparisons in this table, while in the questionnaire, we just have to do the number of pairwise comparison to do will be lower, because as you know, once we have the numbers in this row, we can deduce these ones, okay? So if you have, whenever you say, when I compare LCOE to CO2 emission, I can deduce directly the comparison of CO2 emission to LCOE. So if here the score is 7, here it will be 1/7. If the score here is 9 between LCOE and initial cost, now when I compare initial cost to LCOE, the score will be 1/9. So no need to perform here. If you look at comparisons, so we have 1, 2, 3, 4, 6, 7. Okay, 6 comparison. Okay, but what we need to do in reality is a lower number of comparison, because we have the symmetrical effect. Okay, so all we need to do is to determine the number of comparison required. We can apply a formula, because you need to compare 2 options, but you don't care for the order. If you care for the order, you need to do 6 comparison, because and if you don't care for the order, you just need to do 3, because you know that if I want to compare 2 options, A and B, how many criteria I have here? I have 3 criteria: LCOE, CO2 emission, and initial cost. So I have 3 criteria. So I can put here, I have 3 options to put here to compare with 2 options here. So in total, I can do 3 times 2 comparison equal to 6, in case I am interested in the order of comparison. But since I don't care, and if I do A relative to B or B relative to A, it will be the same response. Okay, so no need to ask people 6 questions. I just have to ask them 3 questions. And from here, we can deduce, if you want, the table of questions, all we have to do, we can start with the first criteria, LCOE, compared to CO2 emission and initial cost. Once we are done with this, we move to the second one, CO2 emission. CO2 emission only compared now to initial cost, and that's it. We don't need to do any other comparisons. So we need just to do 6/2. And now how to fill the table? So in order to fill the table, first I determine the number of pairwise comparison by applying the general formula, which is the number of criteria times n-1/2, which will be equal to 3 times 2/2 equals to 3. Okay? Now, as we said, we draw a table. We have criteria A, B. We list first, we have the first criteria LCOE compared to the remaining one, CO2 emission, initial cost. If we look at our table, okay, when we look at the scores of LCOE compared to CO2 emission and initial cost, we have the score here is larger than 1. This means, and LCOE is the reference. This means that LCOE is more important than CO2 emission. The same here, we have a score larger than 1. So the reference is more important. So when we ask people, do you prefer LCOE or CO2 emission? They will answer, I prefer option A. So I prefer LCOE. And the same for when we ask LCOE versus initial cost, I prefer also A. So the answer will be A, and the score will be as it is, 7 and 9. Okay. If I had here 1/7, for example, instead of 7, then I say the answer will be, I prefer option B, and the score will be 7. When you ask people to put scores, they will not put score below 1. They will put always a score from 1 to 9 if you impose a scale from 1 to 9. Okay, but what will judge if you want what is the preferred option is when they say I prefer A or I prefer B. While here, when you are filling your table, when you fill your table, this is your reference. So if the answer was A, you put the score as it is. And if the answer is B, you put 1 over the score. Okay. So now the remaining questions to ask is to compare just once we are done with comparison of LCOE with CO2 and with initial cost, we move to the second criterion, and we just have to ask one additional question, which is CO2 compared to initial cost. And also here the score is larger than 1. This means that also the answer was I prefer CO2 emission compared to, this criterion is more important than initial cost, okay? But if, for example, it was 1/5 here, then the answer will be I prefer B, and I put a score of 5, okay? So now, this is how we fill the table. So here, since all scores when considering the reference were larger than 1, so here always the answer will be A for the 3 comparisons, and we put the scores which are larger than 1 as they are. Okay, and already, as we said, in case one of the score of reference was smaller than 1, then I put instead of A, B, and I put here the score which is the inverse. Okay, any question on this part? Okay. Now, once this step is done, we are used to such type of questions. So I can they gave me this table, so now I can use it directly. I go back to this table. What I need to do is to get the weights of LCOE, CO2, and initial costs. So as usual, the technique is to do first the summation per column. So I sum these scores for each column. Then I divide for each column, I divide each number by the summation of the same column, okay? And then I will obtain here, when I do 1/, this summation, I will obtain a first weight for LCOE. I will obtain here 3 values of weight from this column, from this one, and from this one. So I can find the average weight by doing weight 1 plus weight 2 plus weight 3 over 3. So if we look at the table summarizing this, so here first I do summation of these three terms. I get 79 over 63. Summation of the second column, 49 over 6, and summation of the third column, 16. Next step, I divide 1 over 79 over 63, which is 63 over 79. 1 over 7 divided by this number, it's 9 over 79, etc. I can fill my my weights if you want. And these three values represent calculations of weights for LCOE. So I want an average value. That's why I will sum these weights and divide by 3. I will get the average weight for LCOE. I do the same. I do the average of these three numbers to get the weight of CO2 emission. And I do the average of these three to get the weight of initial cost. And to make sure that my calculations are right, if I sum the three weights, I should have a total weight of 100%. Okay. Now, once I obtain my weights, I can go back to my initial table. I say the LCOE score should be multiplied by the weight of 0.74, which is 74%. The score of CO2 emission should be multiplied by 20.3%, or 0, which is 0.203. And for initial cost, I multiply by 5.7%, which is 0.057. Okay. Now, next step, as we said, for the scores, we need to normalize them. So since here I didn't mention anything, we can consider a score between 0 and 100. If they impose a score on us, we can just, when you normalize here, you obtain a number between 0 and 1. So you can multiply by the scores that you want to put on. And if you want to put a grade on 30, you multiply by 30, etc. On 50, you multiply by 50. The normalized formula is simply minus observed value plus worst value over minus best value plus worst value. If I apply this formula, I can obtain scores from 0 to 1. And here I multiplied by 100 to convert my scores between for a scale between 0 and 100. After one very important step here is to determine what is the best value and what is the worst value. And it's not always the biggest or the smallest one. I need to look at the criterion. For example, and I need to understand what this criterion means. So if I consider first the LCOE, LCOE represents what actually? It's the life cost of electricity. So in order to produce 1 kilowatt hour, what is the cost that I should put? Okay, so of course, here I need to minimize the LCOE as much as possible to reduce the cost of production. Okay, while if I say the selling price, for example, in dollars per kilowatt hours, then I need to, if I am selling electricity, I need to maximize this price. Okay, so I need to understand what is the criterion considered to know if the best value is the largest or the lowest. So here, since I am paying money to produce electricity, I want to minimize this number. So the alternative representing the smallest value will be the best option. So here, if I compare numbers, I have that this is the smallest number, so it should have a score of 100. And the largest number, which is 1.38, should have a score of 0. And now I just have to normalize these two. And you can always check if your values are, if you want, reasonable. So for example, here, 1.35 is close to the worst value. So I expect is a low score. While for alternative 3, 0.248 is close to the best score. So I expect a high score. Okay, so in case you did any calculation error, you can check that your numbers are reasonable. Now, for CO2 emission, of course, CO2 emission are bad for the environment. They cause global warming, they cause health effects. So we need to minimize them. So here we can consider that the best option will be characterized by the smallest emission. So here, since here alternatives 3 and 4 will not lead to emissions, then I can consider that they will have both the highest score of 100, and the alternative that is characterized by the larger CO2 emission will get a score of 0, and I just have to normalize this number, okay, which is much closer to the worst value than the best value. This is why it will be characterized by a relatively low score. And finally, for the initial cost, of course, also here, I need to minimize as much as possible the initial cost. So the option having the largest initial cost will have the lowest score, and the one having the lower initial cost will have the best score. Okay, while the other two numbers will be normalized to get a score between 0 and 100. Once I am done with this, now I am ready to find, if you want, my total score. All I have to do is to multiply now each score, normalize the score by the weight. So I do, for example, for alternative 1, I do 2.6 times the score of LCOE plus 0 plus 100 times the weight of the initial cost. And then I will be able to get the total score for each alternative. Once I do this, I can rank my alternatives. The highest score will be for the best option and the lowest score for the worst option. So here it's clear that they are already in order. So alternative 1 is from worst to best. So this is the worst alternative with the lowest score, followed by alternative 2, followed by 3, and followed by 4. Okay. Any question on this problem? Okay. Now, I suggested another problem for you to see that we don't have one technique, okay, to rank alternatives, okay? So the previous method of pairwise comparison is a method that we learned together, and it's called the analytical hierarchy process that will allow us to put weights, and then we normalize to put scores between 0 and 100, and we rank the alternatives. But this is not the only method, okay? And sometimes I can give you a new method, but explain it in the exercise, and just you need to apply it, okay? So for example here, the following rating scale is used to rank 5 alternatives proposed to be implemented to a power plant to enhance its performance. So here, if you want, instead of giving first scores with units, okay, and then normalize, here already, if you want, the scores are without units. I just rate, if you want, in a qualitative way. So I say, I consider the following scale unacceptable. If you consider that this strategy is unacceptable, you put a score of 1. You put a rate of 1. If you consider that it's bad, a rate of 2. If it's acceptable, a rate of 3. If it's good, a rate of 4. And if it's an ideal balance between time and money spent, a score of 5. Okay. So here we are putting scores from 1 to 5. Depending, and if you want, it's, well, of course, the other method, when you put scores from 0 to 100, larger, if you want, is the divisions of your scale, the better is, okay? But here, it's, if you want, we are considering criterions that are not characterized here by just directly by numbers. That's why we use this method, okay? And you want to judge based on experience, based on the physical situations that you have, which strategy, for example, can be good or can be bad or can be ideal, okay? So here, your purpose, let's say, is to decide on a strategy to go over in order to enhance the performance of your power plant. And you have several possibilities. The first possibility is to implement energy efficient technologies. The second one is to implement carbon capture and storage. The third is to improve process efficiency. The fourth is to install renewable energy systems. And the fifth one is to use low carbon emitting transportation. Okay. So here, of course, we need experts, if you want, since we are not going and searching for numbers and we are not putting scores with units, we need some experts that can help us to rate these strategies. Okay, so you can ask how to rate these strategies to your, depending, of course, on your problem. So let's say you did a questionnaire and you get an average response, and you were able to rate your 5 alternatives. Now, in addition, we need to decide on the weight. So one method is the pairwise comparison, as we did together before. Okay, and here, what are the criteria that they want to consider? The effectiveness, the cost effectiveness, the feasibility, scalability, and compatibility. You can find weights of these criteria using the previous method, but also you have another technique. You can put weights as number. And here also, you can say, higher the importance of the criteria, I'll put a higher score for it. And here they are putting scores, let's say from 1 to 5 also. So, and they gave, depending on the importance of the criteria, they assessed a number for it. So this is another way, if you want, to consider weights. So instead here of having, if you want, a total of 100, if you want to scale them, you can. But since they didn't ask in this problem to do this, you can keep the numbers as they are. And here, if you want, I give points, 5 points for effectiveness, 4 points for cost effectiveness, 3 for feasibility, 3 for scalability, 2 for compatibility. If you want to transform them to weights, you can do it. All you have to do is to sum, and if you have 5 plus 4, 9, plus 3, 12, plus 3, 15, plus 2, 17. Okay? And then to get the weights in percentage, for effectiveness, you have 5 over 17, for cost effectiveness, 4 over 17, etc. But here, no need to do this. You can keep them as numbers, as they are. Okay? And then you say, what is the technique to assess the score? Higher the weight, higher the score will be, and higher the rating, higher the score will be. So the method will be to do the following. I multiply the weight by the rating. For each alternative, I do this for all criteria, and then I do the summation of the scores to get the total score. And the option that will obtain the largest score is the one to be considered. Okay? So this is a very simple method. Of course, the other one is more accurate. Okay, but as I told you, it depends on if you want, it depends on your problem, on the method you select, etc. Yes? Yes, Leia?
Doctor, shouldn't we divide يعني بالآخر وقت عم نعمل summation
Yes.
shouldn't we divide by 17 لأنه هني قال بدهم إنه
Okay,
بدهم
yeah.
يعرفوا
If did they tell you here they gave you the weights, Leia? Did they tell you to have them in percentages?
Doctor, can you please scroll to the given part?
Yes. Okay. The following rating scale is used to rank 5 alternatives proposed to be implemented to a power plant to enhance its performance. So these are the scores. So you don't need to normalize here because already the scores are without units and they are based on a scale. Okay? So they asked people, do you consider that, for example, you ask people, I want to enhance my power plant efficiency. I'm thinking about implementing carbon capture and storage. Do you think that this strategy is good, acceptable, bad, etc.? You will take the answer. And then you take the average answer from expert people, and then you put that my average rate for this alternative based on, if you want, on its effectiveness was 3. Okay? And then they gave you in the table the weights, yani the points if you want. And here it's like each criterion, depending on its importance, is characterized by points. So if it's more important, I will put more points to this criterion. Okay? So this technique...
Yes, I got this.
You got it?
But I mean,
Okay.
بس وقت قالوا لنا انه rank them according to the obtained result، ما فوق في الرانكينج من 1 ل 5 unacceptable وباد وacceptable وgood وهيك.
Yes. To rank
so
them,
أنا
no. Rank them means what is the best one, what is the worst one. This is what they mean by this. Okay?
I thought انه we should divide by 17 to get an answer between 1 and 5.
No.
Okay.
No need. Okay?
Okay, doctor.
Okay. So now, all you have to do is to find the total score for each alternative, and then to order them. The highest score will be the best one, and the lowest score will be the worst one. Okay? So the technique is the following. All I have to do for each alternative, okay, I consider for each criterion, I do the weight of the criterion times the rating obtained for the alternative, and I find the score. So this is the score for effectiveness. 4 times 5 is the score of implementing energy efficient technologies for cost effectiveness, etc. So I do for all criteria, I multiply the weight times the rating for the considered alternative, and then I can sum the scores obtained.
Doctor, I think in the feasibility in implementing energy, there is an error. 3 times 3 is 9.
Yes, of course, 9. Yes. 3 times 3 is 9, right. Okay. So, and we do the same, okay? We do the same here. For all columns, we do the same. Then we'll be able to, and here we do 5 times 4, 20, 4 times 3, 12, 3 times 4, 3 times 4, plus 2 times 4. We sum these scores, we obtain a total score of 64. Same for the remaining alternatives. And then, as you can see, we can compare the total scores obtained. So the largest score was obtained for installing renewable energy systems. So this is the best alternative to consider. So when we want to rank alternatives, we say that this one obtains the highest score. So this is rank 1. Now we have for rank 2, 2 options obtained exactly the same score. So for both of these, we can give rank number 2. Implementing energy efficient technologies, rank 3. And finally, for the last one, we have implementing carbon capture and storage, rank 4. Okay.
They'll change because غيرنا feasibility. يصير the third one is the implementing carbon capture.
Okay. You mean if we take into consideration the calculation error here? Yes. Okay. Okay.
Yes.
Okay. I will fix this. Okay. Okay. Another problem.
Professor?
Yes.
For the exam, it's going to be the same method as the 2 first problems.
Look, in case I want to suggest a new method, it will be clearly explained. Okay, don't worry. And I will tell you. For example, here I can give you. If I give you this problem, I can tell you to put score. The formula used to calculate score is to multiply the weight by the rating, and it will be clear what is the method to use. Okay. So don't worry about it. In case you have anything new, it will be well explained in the given. Just you have to apply it. But these are the most two used methods. Okay.
Okay.
Okay. Now, in another problem, we have that in this problem, we are suggesting, okay, to do a modification in a certain institution, and we want to study the total cost generated through 10 years, okay? And they told us that the institutions proposed to do a combination of cash and stock deal worth more than $10 billion and integrated the product lines. Food engineers and food designers and food safety experts made many cost estimates as they determined the needs of consumers and the combined company ability to technologically and safely produce and market new food products. At this point, only cost estimates have been addressed, not revenues or profits. Of course, when you do the overall economic analysis, financial analysis or economic analysis, you need to consider costs, revenues, and profits. But in this problem, we are just interested in the life cycle cost, and we want to calculate this life cycle cost over the 10 years, okay? Now, of course, this problem is heavy as calculation. That's why I prepared, I want you to see how we can prepare Excel sheets that can help us into doing the calculation. Of course, in the exam, I will not give you such a huge calculation to do. We can use several formulas and we'll discuss them together, okay? But we have a lot of computations here. So in the exam, in case we have similar problems, and you will not have 10 years, it will be maybe 2-3 years. So calculation will be feasible. Okay, so don't worry about it, but I just want you to understand the technique. And here we can see, if you want, several types of costs, several types of increments. And sometimes we talk about an increase in percentage. Sometimes we talk about a constant increase for each year. So we'll see how to deal with these differences given.
Professor,
Yes, Salma.
for the exam, how long is the exam?
It's
Next week?
around 75 to 130 to 1 hour 30 minutes. Yeah. And it should be done in 75 minutes, but in case you need some extra time, I will give you. But I think it should be within 75 minutes, you will be done.
In what room is it? In our classroom? Oh,
No, I reserved a room. I will send you all details. Okay.
okay, thank you.
It's during the class time, right, doctor?
Yes. If you can do it earlier, all of you, it's fine for me. We can discuss this after if you want, after the session. Okay? Okay, so let us see here first. We have, for the consumer habits study, we just need at year zero, $0.5 million. You know that in LCC, okay, we will evaluate the net present value of all costs. In economy, we have several techniques. Sometimes you just have to fix a time. In some analysis, they say, let us calculate all values as future worth, or let us calculate values as annual worth. All of these techniques are right, okay? But in general, one of the most used method is to calculate at the total value at present time, okay? So we will convert all costs back to year zero. And this cost is already at year zero, so we don't need to do any calculation. It's 0.5. Now, for preliminary food product design at year one, the cost is 0.9 million. So to have the net present value at year zero, all we have to do is the corresponding value at year zero. We just have to consider the discount rate. They said in this problem, calculate the LCC for a lifetime of 10 years and for a discount rate of 18%, okay? So just I have to divide 0.9 by 1.18 to the power 1, okay? Because the formula is, I just take the cost, C1, at year 1, divided by 1 plus A, and since the discount rate is 18%, So 1.18 to the power number of year, I am in year 1. So 1.18 to the power 1. Similarly here for preliminary equipment plan design, exactly the same. It's in year 1. So same formula to